Alright, so number 48 is a difference of perfect squares. When you think about factoring, you got to think about what you see, and in this case you don't have a middle term, so if you wanted to write it like that, you could. X squared plus 0x minus 25. If you don't remember that's a difference of perfect squares. And you can say, what are the factors of negative 25 that add up to 0? And that's positive 5 and negative 5. But if you do recognize it, then you can just say, okay, x squared minus 25, so x plus minus the square root of 25 is 5. And there you go. So that's that. On 49, there is, this is 1 as well. So we're trying to find the factors of negative 56 that add up to positive 1. And you can go through all the factors if you want to, but they are 7 and 8. Multiply to give me 56, and I need a negative 56, which means one of them needs to be negative, but I need a positive one when I add. So a negative 7 would be good. So then we got m minus 7 and m plus 8. And remember that you can always check these and redistribute them back out. M squared plus 8m minus 7m and m minus 56, and see if you get the same thing, and you do. So number 50, you've got 4x squared plus 5x plus 1. So because it has a leading coefficient other than 1, that means we need to do either bottoms up or another method if you like factor by grouping or anything like that. So we'll multiply 4 times 1 and say I need the factors of 4 that add up to 5. So we really only got 1 and 4 and 2 and 2, but 1 and 4 are the ones that add up to 5. So I'm going to write x plus 1 and x plus 4. But then remember that 4 is what we multiply by, so we're going to go back and divide. And so to factor, this doesn't simplify, so we bring it back up. 4x plus 1. This simplifies down to a 1, so we're left with x plus 1. And that is the factored form of that. So 4x plus 1 times x plus 1. On number 51, we've got a leading coefficient again, so we're going to multiply by 2. So 2 times negative 21 is negative 42. And we're looking for the factors of negative 42 that add up to negative 1. So 42 is 1 and 42, 2 and 21, 3 and 14, and 6 and 7. 6 and 7 have a difference of 1, and I need a negative 1 when I add them and a negative when I multiply them. So one of them is negative, and the larger one is negative in order to add up to a negative 1. So that means we've got r plus 6 and r minus 7. We multiplied by a 2. That's what we're going to go back and divide by. This simplifies down to a 3. Yes. 4? What's here? Okay. It's like if it's just to go pick up your lunch, then no. Okay. Yep. In case anyone in the video is worried, Nikki is leaving, but she will be back. And so, this one does not simplify, so we bring this back up to r minus 7. And there you go. So that one is just r plus 3 times 2r minus 7. Alright, number 52. Number 52, right off the bat, just looking at it, these don't have the same radicands. This one has a 3, that one has a 12, that one has a 27. But if I were to simplify the radicals, then maybe I would have the same radicand. So 3, that's as simple as it gets. 12, however, I can simplify by 4 times 3, because this perfect square 4 goes into 3, and 27, 9 goes into it 3 times. So I've got negative 2 square roots of 3, minus 3 times the square root of 12, but the square root of 12 can be written as the square root of 4, which is 2, times the square root of 3. And then minus 3 times, well, the square root of 27 is the square root of 9 times 3. The square root of 9 is 3 times the square root of 3. So I've really got negative 2 square roots of 3, minus 6 square roots of 3, minus 9 square roots of 3, which is a negative 17 square roots of 3. Pretty sure. If I can add. Number 53 is a little bit meaner because it's got powers. It's the cubed root, but we can go ahead and see what we can do. Okay, the cubed root of 6 is not, it's not a whole number. There's nothing really I can do with that, so I'm going to leave it alone. 24, the only perfect cube that goes into 24, because 27 is too large, is 8. 8 goes into it 3 times. So I'm going to think of this as the cubed root of negative 8 times 3. And 81 is actually 3 to the 4th, so you can look at it as a couple different ways. You can think of it as the cubed root of 3 to the 4th and do it like we simplify the radicals before, or you can think it's, that's a terrible 2, 27 times 3, because the cubed root of 27 is 3. So I've got negative 3 times the cubed root of 6. The cubed root of negative 8. Guys, what is the cubed root of negative 8? Negative 2. Cubed root of a negative is still negative, right? So I've got plus 3 times a negative 2 times the cubed root of 3. So the cubed root of negative 8 is negative 2, and then that's 3 stays on the inside. The cubed root of 27 is 3, and then times the cubed root of 3. It's very hard to see with it all being red. So I've got this times the cubed root of 3 and this times the cubed root of 3. So I've got negative 3 times the cubed root of 6 minus 6 cubed roots of 3 plus 6 cubed roots of 3, which cancel each other out, leaving the final answer as negative 3 times the cubed root of 6. There you go. Okay. Maybe he just missed you. No. You know what he wanted to talk about. Okay. Alright. Is that one cool? Does that make sense? Okay. So, matrices. When you are adding or subtracting matrices, they have to have the exact same dimensions, and it's row by column. There's one row, 2 columns, so this is a 1 by 2 minus a 1 by 2, which is exactly what it needs to be. And you literally just subtract each term with its corresponding term. Negative 6 minus 3 is a negative 9. 3 minus a negative 2 means 3 plus 2, that is 5, and there's your answer. Number 55 has to do with, well, we've got addition, and they're both 2 by 2s, but this has a 2 in front of it, so we're basically going to multiply all of these ones by 2 and then add them to those. So, ooh, I got to the same color. That would be tragic. So, well, I'll use that color. Okay. So if you want to, what you could do is just say, okay, this is 2, this is 8, this is 10, and this is negative 12. And just multiply it like that, and then add. 2 plus 0 is 2. 8 plus a negative 4 is 4. 10 plus 4 is 14. And negative 12 plus a negative 1 is negative 13. And so there's your answer. 2, 4, negative 4. Sorry, 2, 4, negative... 2, 4, 14, and negative 13. Good golly. Okay, number 56. Number 56 is multiplying matrices, which is quite a bit more involved. So, first you got to see if you can. This is row by column. This is a 3 by 2 times a 2 by 2, which means because those are the same, we can multiply them, and it means that the dimensions of my answer are going to be a 3 by 2, which means it's going to look like this. So it's going to be a 3 by 2. Okay, so let's start multiplying. Remember, we multiply row by column. So, row by column means 0 times 3 plus 1/3 times 1/2. Row by column means 0 times negative 5 plus 1/3 times 4. row by column, so the second row times the first column goes in the second row, first column spot. 6 times 3 plus 1 times 1/2. Row by columns, second row, second column. 6 times -5 plus 1 times 4. Row by column, I've got bottom row, first column, so I've got 1 times 3 plus 4 times 1/2. And I've got bottom row times second column, so 1 times -5 plus 4 times 4. I'll see some of you tonight. Good. So now we just simplify. So I've got 0 times 3, which is 0. 1/3 times 1/2 is, you just multiply straight across. So I've got 1 times 1 over 3 times 2, so 1/6. So the first term is 1/6. 0 times -5 is 0. 1/3 times 4 is 4/3. 6 times 3 is 18 plus 1 times 1/2. 18 plus 1/2, so 18 plus 1/2. I'm going to write that as a fraction, which means I'm going to find a common denominator. So 18 over 1 plus 1 over 2, multiply by 2 on top and bottom, and I've got 36 halves plus 1/2, which is 37 halves. 6 times -5 is -30 plus 4, so that's -26. 1 times 3 is 3, 4 times 1/2 is 2, so 3 plus 2 is 5. 1 times -5 is -5 plus 16 is 11. And that is my answer. Number 57 is a 1 by 2. So I've got a 1 by 2 times a 2 by 3, which means my answer is going to be a 1 by 3. So 1 row, 3 columns. So 1 row, 3 columns. And then let's just multiply it out. Hey Max, what color was your calculator? Okay, well I have another calculator then. Okay, so row by column, so I'm going to multiply 5 times -5 plus 3 times a -1, which is -25 minus 3, so -28. The next one is row by column, so I'm going to multiply 5 times -5/3 plus 3 times 5, which is a -25/3 plus 15. Common denominator is 3, so that is 3 times 15 is 45. -25 plus 45 is 20, so that is 20/3 is my middle term. And row by column, 5 times 5, that's a lot of 5s, a lot of 5s, plus 3 times -2 means 25 minus 6, which is 19. So that is my final answer. For that one. Okay, number 58 says find the inverse of each function, find the domain and range of the original and its inverse on numbers 58 and 59. So, number 58, we start with just replacing that with y. And what I want to do is switch x and y and solve to find the inverse. So the first thing I want to do is find the inverse. So I've got x equals 2 square roots of y minus 5 plus 4, and then I want to solve for y. So I'm going to subtract 4 first. And then, I don't know why I switched colors, but whatever. And then I'm going to divide by 2. X minus 4 squared, or x minus 4 divided by 2. I don't know why I did that. Equals the square root of y minus 5. Okay, I did that because the next thing I'm going to do is square. So the next thing I'm going to do is square both the sides. So I'm square that and square that. So I've got, okay, you've got two ways to think of this. I'll address that in a second. Okay. So you've got x minus 4 over 2 squared equals y minus 5. So then you want to add 5. So you've got x minus 4 over 2 squared plus 5 equals y inverse. But if you leave it like that, then you're wrong. So what I can do is I can think of it in multiple ways, but I'm going to sketch in general the original and its inverse. The original function is a radical, just a single radical shifted to the right 5 up 4. And it looks like this. Okay? So when I graph this parabola, like I said, there's multiple ways to think of this. X minus 4 over 2 squared plus 5. You can think of it as 1/2 times x minus 4 squared plus 5, which is a horizontal stretch by a factor of 2. Either way, it's just a parabola shifted to the right 4 and up 5. Or you can think of it as distribute the power, and you can think of it as x minus 4 squared over 2 squared, which is 4, plus 5, which just means 1/4 x minus 4 squared plus 5. I don't really need to be able to sketch the function, or like actually plot points. I just need to be able to see what it looks like. It's a parabola shifted to the right 4 up 5. So to the right 4 up 5. Now normally parabolas are a full situation like this. Yeah? But we're talking about a reflection of only this. And I know that the domain and range of the original, so the domain is from 5 to infinity. I'm talking the video. 5 to infinity. And then the range is low to high. The lowest is 4 and up to infinity. Can someone shut my door?
I got it.
And then that means that the domain and range of the inverse are flipped. The domain should only be 4 to infinity, which means this is not part of it. Okay, and the range is 5 to infinity. But either way, even if you do this, you're still not correct if you don't say comma. This is only for x is greater than or equal to 4. So my inverse is this, and my domain and range are this. And my domain and range of my original are that. So that is the answer to number 58. I'm just going to kind of attach that. Alright, number 59. So number 59 is a quadratic, so it's the exact opposite situation as number 58. We are starting with the quadratic and we need to end with the radical. So this is y. So I've got x equals 4y squared minus 4. I'm going to add 4. I'm going to divide by 4. And then I'm going to take the square root. And when you take a square root, you have to remember that there's two answers, both plus and minus. So y equals both plus and minus the square root of x plus 4 divided by 4, or the square root of 1/4 x plus 4, or the square root of, you could take the square root of the top and the square root of the bottom, which is 1/2 the square root of x plus 4. I really don't care, because all 4 of these are equivalent. The only issue we have at this point is making sure that you could just sketch it so that you can find the domain and range. So the original function is a quadratic with a vertical stretch by a factor of 4, and shifted to the, or shifted down 4. So, y is a parabola shifted down 4. That is my original function, this parabola. Why am I hearing cards? Okay, so my domain for the original function is all real numbers from negative infinity to positive infinity because it goes all the way left and all the way to the right. And my range is negative 4 to infinity. My inverse is this radical, and we shift to the left 4. In any of these cases, we know we shift to the left 4. And so I really don't care if you know that the 1/4 is the horizontal stretch by a factor of 4 versus the vertical compression by a factor of 1/2. As long as you can sketch, and I mean, I do care. But like on this problem, as long as you can sketch that it's both the positive and the negative radical as a reflection of this parabola, then you're good. However, you do have to realize that there are 2 domains and ranges because you've got 2 different functions that make up your inverse. The domain of both of them is negative 4 to infinity. The range of the bottom one is negative infinity up to 0 on the y-axis, and then pick back up at 0 and go up to infinity. And that is the domain and range of your inverse on number 59. So, my inverse, I should say. And then, all of that. Okay. Number 60. We need to find the inverse, but you do not have to find domain and range, so you just have to find it. We make this a y, so x equals negative y plus 4 quantity cubed minus 2. So the first thing you want to do is add the 2. X plus 2 equals negative y plus 4 to the third. I have a lot of people that take cubed roots at this point. You cannot do that. You have to make sure that the power is alone, and right now there's a negative 1 in front. So you need to divide by a negative, which makes this negative x minus 2 equals y plus 4 cubed. In order to get rid of the power of 3, we're going to take the cubed root. So I've got the cubed root of negative x minus 2 equals y plus 4, and then to solve for y, I'm going to subtract 4. So y inverse equals the cubed root of negative x minus 2 minus 4. And number 61. This is a y, so we've got x equals the 5th root of y plus 3 divided by 2. And just start undoing all the operations. So the first thing you want to undo is the power of the 5th root, so we raise it to the 5th power. So if you raise both sides to the 5th power, they cancel each other out. We're left with x to the 5th equals y plus 3 divided by 2. Multiply both sides by 2. We've got 2x to the 5th equals y plus 3, subtract 3. And you get y inverse equals 2x to the 5th minus 3. And that's the end of page 5.